Hi, the SI meteorologist Paul Dorian here with a brief discussion on GOES and POES. GOES stands for the Geostationary Operational Environmental Satellite, and POES stands for the Polar Orbiting Environmental Satellite. Here at the SI, we have done lots of work with respect to some satellite systems over the years, working with NOAA and NASA and the U.S. military on such systems as Landsat and DMSP and NPOES, which are polar orbiters, and the GOES satellite system, which is not a polar orbiter, it's a geosynchronous satellite system. These have two different kinds of orbits. We'll talk a little bit about that in a moment. But first, let's get a little background on the history of satellite imagery. The very first satellite image was taken on April 1st, 1960. This was indeed a very important event in the world of weather forecasting, a major milestone, right up there with the advent of computer forecast models and the introduction of Doppler radar. The introduction of satellite imagery was crucial to the monitoring of weather systems like tropical weather systems and small-scale weather systems like severe thunderstorms over the eastern and central part of the U.S., for example. Here's the very first satellite image. You can see the Canadian maritime provinces right here, where there were clear skies, and the northeast U.S. coast right here, where there were clear skies as well, clouds just to the west, maybe over the Midwest. Nothing spectacular about this particular scene, but the event itself was a spectacular event and a major milestone. This particular satellite system was a Tyros 1. It lasted for about 78 days, was highly successful, sent back thousands of pictures, a polar orbiter, and we'll talk about that kind of a satellite track in a moment. But this proved the point that satellite imagery could in fact be done, and this was a major advance in the world of weather forecasting. Well, there are, in fact, two different kinds of satellite orbit paths here. The geosynchronous is what GOES operates under, and the sun-synchronous is what the POES orbiting satellites operate under. The geosynchronous is a path that the satellite system orbits the equatorial plane of the Earth at the same speed that the Earth rotates, so it's over a fixed location at all times. The GOES provides images every half hour, both visible and IR, and, for example, covers the U.S. In a fashion like we never had before, of course. GOES East covers the eastern two-thirds of the U.S. and the western part of the Atlantic, and the big advantage of the GOES satellite system is it allows forecasters to view such small-scale features as thunderstorms, severe thunderstorms, tornadic thunderstorms, for example, and as well it covers the tropical Atlantic region, so we have a much better way of monitoring the development and the movement of tropical systems. Of course, before 1960, before there were satellite imagery, we had no idea really what was out there over the ocean except for ship observations that could be relayed back to land. But this is a major milestone, of course, and GOES is a tremendous asset for short-term forecasting and moderate-term forecasting, especially in the U.S. where there's so many severe thunderstorms due to the nature of the geography and the combination of the land and the ocean and the Gulf of Mexico. And, of course, we're very close to the tropical Atlantic and can be affected by tropical systems. Meanwhile, the polar orbiting systems, that includes such things as Landsat and NPOES and the DMSP, provide an advantage that they cover the globe on a daily basis. Roughly about 14 orbits per day cover the globe for these polar orbiters. And in another video, we talked about computer forecast models and the input data, including surface observations and upper air observations, that has some gaps between these reporting stations. Polar orbiters are used as well to provide some input data to computer forecast models, especially because they usually fly over some data poor regions near the poles or over oceans, for example, where we just don't have that kind of coverage for surface and upper air observations. Here is, in fact, a map prepared by NCAR that shows a polar orbiting track, and again, it tends to go down over some data poor regions over the oceans, for example, or near the poles. They don't go exactly over the poles, but this is a typical track of a polar orbiter. And again, the geostationary satellite system is fixed at about 22,300 miles above the Earth and will focus on the same area, but that is a very beneficial, as are these polar orbiters, which cover the globe maybe 14 times a day. Well, let's now move on to a couple of examples of these satellite systems. This is a visible satellite image from the GOES East satellite system. Again, the GOES East covers the eastern two-thirds of the U.S. and the western part of the Atlantic. You can see, for example, a little band of clouds here that's associated with a cold frontal system that's moving into the mid-Atlantic region. And down a little bit farther, there's a band of clouds here that look kind of suspicious, perhaps a tropical or the beginnings of a tropical feature. And again, this is one of the main advantages of the GOES satellite system. It allows the U.S. forecasters to monitor the development and the movement of tropical systems in this part of the Atlantic. We are now just beginning hurricane season, and you can bet that GOES imagery will be used every half hour over the next few months. Finally, this is an actual path of a polar orbiter, in this case Landsat 7. It comes from a USGS website. If you Google Earth now, you'll get to this USGS website. The previous GOES satellite image was provided by a NOAA website. Here is the path taken by this particular polar orbiter in this particular moment. This is real time. It's coming over the U.S. and getting some clear skies actually over much of the region. But again, this is a typical path of a polar orbiter, and the combination of polar orbiters and geostationary satellites provide tremendous benefits to the world of weather forecasting, and will continue to do so over the next several years. That's it for now. I'm the SI meteorologist, Paul Dorian.